Student, welcome to physics classes. Today we have to start application of Gauss theorem, and the very first application is field due to infinitely long straight wire. Before starting this topic, let us be familiar with these three words: charge density. Charge may be given along the line, charge may be given on the surface, charge may be given within the volume of a body. When charge is uniformly distributed along the length of a conductor, it is called linear charge density. Similarly, if the charge is spread uniformly on the surface of a body, suppose you have a spherical shell and the charge is distributed on the surface of a spherical shell, then it is called surface charge density. It is denoted by sigma. In place of a spherical shell, suppose you have a sphere that is solid. Now the charge is distributed along the volume of the sphere. When the charge is distributed over the volume of the sphere, it is called volume charge density and it is noted by rho. So we have to deal with linear charge density, that is charge per unit length, and surface charge density, that is charge per unit area. Now come to the topic. The topic is field due to infinitely long straight charge wire. There is a long straight charge wire, infinitely long. Infinitely long means the distance r of the point P from the wire is very small in comparison of the length of the wire. So this is a wire. Due to this wire, we have to calculate electric field at a point P on the surface of the wire. When we have to calculate electric field due to this wire, we have to consider a convenient Gaussian surface. GS means Gaussian surface. We shall choose the Gaussian surface as per our convenience. For the current problem, the Gaussian surface is cylindrical Gaussian surface of radius r and length di. The Gaussian surface is of radius r and length di. This is what radius r and the length is l. Now, charge enclosed by this Gaussian surface will be the charge which is on the wire of this length L. The charge density is lambda. Therefore, the charge on this wire of length L will be equal to what? Q is equal to L lambda. So, clear students, the charge within the Gaussian surface will be equal to what? L lambda. Now, we apply Gaussian surface. We apply Gauss theorem over the Gaussian surface. What is Gauss law? What is Gauss theorem? Gauss theorem states that total electric flux passing through a closed surface equal to charge enclosed by the surface divided by epsilon naught. And the value of charge is what? L lambda. Integral E vector dot ds vector is equal to what? Q upon epsilon naught. Now, a cylinder has what? Three surfaces. There are three surfaces of a cylinder. There is one curved surface and there are two side caps. There are two side caps and there is one curved surface. So there are three surfaces. I have written this expression into three steps: S1, S2, S3. S1 side cap, S2 curved surface area, S3 again side cap. You see very closely that the electric field due to line of charge will be radially outward, that is in the vertical plane. Electric field is always in the vertical plane due to wire. When we consider the point P on the surface, the area vector will also be in the direction of electric field. Area vector will be in the direction of electric field because area vector is taken normal to the surface at that point. So at this point, electric field and area vector will be in the same direction. But if you see on the side caps, the electric field is radially outward and the area vector is normal to the surface, that is along the length of the wire. Electric field and area vector will be perpendicular to each other. That's why theta will be 90. So remember